Hello, this is our video case study on model-based enterprise. Model-based enterprise is an organization that uses an approach to product development, manufacturing, and lifecycle support that uses a digital model to drive all engineering activities. The MBE approach uses data models rather than documents as the data source for all engineering activities throughout the product's lifecycle. The core MBE tenet is that models are used to drive all aspects of the product's lifecycle, and that data is created once and reused by all downstream data consumers. The picture on the slide shows all of the different parts of the engineering process that MBE helps with. Engineering graphics were first found in 2000 BC, where the first drawing was carved on a tablet for a temple in the Babylonian Empire. Moving forward, the perspective drawing technique was invented during the Renaissance period, which is between 1300 and 1500. Then descriptive geometry was invented by Gaspard Monge in 1765. Orthographic projection was invented during the Industrial Revolution period, which was between 1770 and 1850. And then in the 1880s, the 2D CAD systems were developed and then used by many companies after that. Then 3D CAD systems were developed in the 1990s, which led to model-based enterprise becoming more of a technique that companies used. The first step to an organization achieving a fully model-based enterprise is MBE readiness. In this step, the company takes its first step towards formalizing processes, making them more model-centric and for effective design to manufacturing collaboration, implementing 3D model-based definition, best practices, and migrating PMI, GD&T, and annotations from 2D drawings to 3D models. Elevating customer design and collaboration processes are ways to make the company MBE ready. The next stage is MBE development, which includes the deployment of Inner Core, which integrates the company enterprise data repositories to harvest complete engineering product definition. Then repurposes the data into fit-for-purpose engineering and manufacturing MBE documents such as 3D PDF and 3D HTML. The third stage is MBE scalability, and in this step, the company will help the customer in expanding their definition and usage of MBE processes documents to address additional use cases such as quality, servicing, and maintenance, thereby establishing MBE approach across the extended enterprise. Many departments within an organization have involvement with MBE, one being the engineering department. When a company starts using MBE, this group would change a lot as their drawings and writings would be digitized and the employees would have to learn new techniques for working together with the new software. MBE would improve collaboration and focus efforts on a single CAD model that can centralize all of the engineering data. For those in design, intercompany communication would become digitalized and center around the product data management system in place. Intercompany communication would become far more rapid as real-time sharing of assets and intellectual property enhances collaboration and increases interdependence, thus increasing the importance of properly managed design. Additionally, those involved in analysis would now have complete digital models to work with, increasing precision, decreasing ambiguity, and improving workflows, as well as being able to run digital manufacturing software that can help simulate the manufacturing process. For all involved, a rapid increase in pace would be necessary to adapt as the organization transitions to become more involved in MBE. One digital transformation initiative is the digital thread, which refers to the communication framework that allows a connected data flow and integrated view of the asset's data throughout its lifecycle across traditional functional perspectives. MBE enables the digital thread through usage of the PDM systems and the ability to transfer data easily between different stages of the product's lifecycle. The digital twin is the virtual replica of a physical device that data scientists can use to run simulations before an actual device is built and deployed. Since MBE is driven by the digital model, it helps enable the digital twin because it allows for it to be made and used to the greatest capacity that it has. Product lifecycle management refers to the handling of a good as it moves through the typical stages of its product life: development and introduction, growth, maturity/stability, and decline. PLM is one of the basic components of MBE and helps keep the company's CAD and documents organized from the product start to finish. Some of the main points of MBE approach are the standardization of parts, CAD reusage, and using simulations in order to streamline the design process since it is easier to create devices that already have parts that are standard, and simulations help work out any issues that the device may face.
There are many benefits of implementing the MBE system, but they can be summarized down to these 4 key benefits. MBE saves time in marketing. It also reduces production costs by improving the design and fabrication of the tools used for production. Streamlining the whole development process by cutting down the assembly hours and minimizing the necessity for reworks is also one of the benefits. Improving collaboration between the engineers is also another significant benefit of having an MBE system in any large corporation. Now, why add MBE data to off-the-shelf parts? Now, there was not much of a resource to find the exact reason why corporates would need to add MBE data to parts they purchase off the shelves. However, I was able to make assumptions based on our classes and other literature reviews. Assembling the parts into a production-ready product comes down to how well each part fits with each other. Most of the time, parts that are created within the company by the engineers need to play well with small off-the-shelf parts like standard nuts and bolts. And when engineers manufacture certain parts, they need to know the exact dimensions of these essential parts in order to create, for example, a hole that fits perfectly with bolts that the company had purchased. And this way, the engineers don't have to struggle to find out what the dimensions are for smaller purchased parts every time they are trying to design something. Now, this all sounds all very good. So why wouldn't all companies just switch out their existing outdated system right away? Well, it turns out implementing a new system to an existing company faces a number of challenges. CAD and PLM tools that are used in the industries are optimized for drawing-based workflow, not necessarily for a model-based process. Also, it is sometimes difficult for suppliers to access the model-based documents due to the lack of software the document requires. Importing legacy data for some companies could be a struggle because model-based documents in nature might make more sense in the parts created going forward, but not necessarily for taking the old parts to the MBD level. Large upfront cost of having to train the employees on a new process and the idea of changing the culture of an already well-established company also might run into opposing opinions. In summary, a model-based enterprise is an organization that uses a model-based approach to developing a product. The implementation of such a system is relatively new. Generally, a model-based approach is achieved in 3 different stages, which are readiness, deployment, and scalability. Within an enterprise, engineering, design, and analysis departments see the most changes by implementing a model-based system. We have also found out that implementing a model-based approach has multiple benefits, such as saving time and money in production. On the other hand, there are also challenges that stop certain enterprises from using such workflow. And that was the end of our presentation. Thank you all for listening.